So the center of two coils are separated by a distance of 0.1 meter. At the center of one coil, due to the current flowing through the same coil, dipole andrenu, two equal and opposite charges. Is current going over the EMF or lagging behind it? Hello students, this is SD Sir, yet again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. We will be working out model question paper 9 today, where I will solve numericals from this model question paper. The first one, the problem says, in an electric dipole, there is an electric dipole. The charges are +2 nanocoulomb and -2 nanocoulomb. Dipole andrenu, two equal and opposite charges. Two charges having the same magnitude but opposite in polarity. So here the two charges have magnitude +2 nanocoulomb and -2 nanocoulomb. And they are separated by a distance of 0.02 meter. Distance of separation between the two charges, 0.02 meter. I have to calculate the dipole moment and also the electric intensity due to the dipole at a point on the axis and equatorial line. So first we collect the data where we know Q1 is +2 nanocoulomb and Q2 is -2 nanocoulomb. The distance of separation is given 0.02 meter. So 2L is 0.02 meter. Very clearly in the concept we have understood the dipole length or the distance of separation between the two charges is 2L. So first I will calculate the dipole moment, which is P, which is equal to Q into 2L. Remember the expression dipole moment, product of the magnitude of any one of the charges magnitude and the distance of separation between them. So this is 2 into 10 power minus 9 into 2L is 0.02. So on simplification, dipole moment is 4 into 10 power minus 11 coulomb meter. Now I have to calculate the electric intensity due to this dipole on the axis. So first we are calculating along the axis, where we know that E is 1 by 4 pi epsilon naught 2pr divided by r square minus a square the whole square. So this is the expression for the electric intensity at a point on the axis. So this turns out to be 9 into 10 power 9 to dipole moment into 0.04 divided by 0.04 whole square minus 0.01 whole square. So on simplification, this is 1.28 into 10 power 4 Newton per coulomb. What is the expression for the dipole moment on the equatorial line? So we have E equals 1 by 4 pi epsilon naught P divided by R square plus A square to the power 3 by 2. And this is an assignment for you all. Simplification for the equatorial line. The next one. The problem says two identical coils, are placed coaxially with their centers separated by a distance of 0.1 meter. So the center of two coils are separated by a distance of 0.1 meter. A current of 0.5 ampere passes through each coil in opposite direction. So there is a current of 0.5 ampere which is passing through each coil in opposite direction. If the radius of either coil is 0.5 meter and number of turns is 40, find the resultant magnetic field at the center of either coil. So there are two coils which are placed coaxial. Very clearly, they are placed coaxial with their centers separated by a distance of 0.1 meter. The criterion here is, the hint here is, the current in the coils flow in opposite directions. So this is I1, I assume this is I2. Current flows in opposite direction. 0.5 ampere is the magnitude of the current. Radius of each coil is 0.05 meter and number of turns is 40. There are 40 turns in each coil. I have to calculate resultant magnetic field at the center. So first, I will calculate magnetic field at the center of one coil due to the current flowing through the same coil. Magnetic field at the center of one coil due to the current flowing through the same coil. I call that B1. So we know magnetic field at the center is mu naught by 4 pi 2 pi IN by R. ಈ expression na circular coil magnetic field derivation in ತಗೊಂಡಿದ್ದೀವಿ. So this is the magnetic field at the center. So on substitution, mu naught is 4 pi into 10 power minus 7, 2 into 3.14. Current flowing is 0.05 into number of turns is 40. The radius is 0.05 meter. So this on simplification is 2.5 into 10 power minus 4 Tesla. So this is the magnetic field at the center of one coil due to the current flowing through the same coil. Now I calculate magnetic field at the center of one coil due to the current flowing through the other coil. So the axis now, so we know B2 is, so here again we had a 4 pi, mu naught by 4 pi, 2 pi, IN R square plus x square to the power 3 by 2. And on simplification, this is 0.22 into 10 power minus 4 Tesla. But I want a resultant magnetic field at the center. And keep in mind, the current in both the coils flow in opposite direction. So B is B1 minus B2. Why B1 minus B2? That is because current flows in opposite direction. And therefore, 2.28 into 10 power minus 4 Tesla. The next one. The problem says a source of alternating EMF of frequency 50 Hertz is connected in series with a resistance of 200 ohms, inductance of 100 millihenry, and a capacitance of 30 microfarad. I have to check whether current leads or lags the EMF. Is current going over the EMF or lagging behind it? And by what angle the difference happens? So students, first I calculate XL, which is omega L, which is 2 pi FL. All these expressions, pretty number of times I have used while problem solving from concepts, model question papers and so on. So this is 2 into 3.14 into 50, 100 into 10 power minus 3. And on simplification, this turns out to be 31.4 ohms. So this is the value of XL, where XL is also called inductive reactance. Now I'll calculate XC, 1 by 2 pi FC, capacitive reactance. So this is 1 by 2 into 3.14, 50 into 30 into 10 power minus 6, which is 106 ohms. So here on calculation, very clearly, XC is greater than XL. So, XC greater than XL. If XC is greater than XL, what type of circuit it is? Purely capacitive circuit, which means here current leads EMF. And by what angle is also asked. So I use the expression tan phi equals XC minus XL by R, and on calculation phi turns out to be 20 degrees 30 minutes. See, easy to score a 5 mark here. The next one, a photon of energy 8 electron volt is incident on a metal surface of threshold frequency 1.6 into 10 power 15 hertz. What will be the kinetic energy of the electrons emitted? Now, energy of the photon is given to be 8 electron volt. Threshold frequency. So the threshold frequency mu naught is given to be 1.6 into 10 power 15 hertz. So what is the work function? We know it is h mu naught 6.625 into 10 power minus 34 into 1.6 into, and to convert this into electron volts, divided by 1.6 into 10 power minus 19, which is equal to 6 electron volt. Now go back to Einstein's photoelectric equation. So kinetic energy is energy of the photon minus work function 8 minus 6, which is 2 electron volt. So students, I have worked out sufficient numericals which will guide you all, which will help you all to solve the last section of the question paper. Practice hard. Have a nice time. Thank you.